Imagine cutting through metal using nothing but a thin wire and a controlled spark. This might sound like something out of a science fiction movie, but it's a reality thanks to wire EDM technology. That's the magic of wire EDM, or electrical discharge machining. This process is revolutionizing the way we approach precision machining, offering capabilities that were once thought impossible. This incredible technology is changing the game in precision machining. Workshops around the world are now equipped with wire EDM machines, allowing engineers to achieve levels of accuracy and detail that were previously unattainable. It allows us to create incredibly intricate shapes and designs. Whether it's for complex aerospace components or delicate medical devices, wire EDM can handle it all with ease. Wire EDM is a non-traditional machining process. Unlike conventional methods that rely on cutting tools, wire EDM uses electrical discharges to precisely remove material from a workpiece. It uses electrical discharges to remove material from a workpiece. This method is not only highly accurate, but also minimizes the stress and deformation that can occur with traditional machining techniques. A thin, electrically charged wire acts as an electrode. This wire is guided along a programmed path, allowing for precise control over the cutting process. It travels along a programmed path, cutting through even the toughest metals with incredible accuracy. The result is a clean, precise cut that meets the exact specifications required. This process is perfect for creating complex shapes and delicate features. From intricate gears to fine medical instruments, wire EDM can produce parts with exceptional detail and precision. These would be impossible with traditional cutting tools. The ability to cut without physical contact means that wire EDM can achieve shapes and features that other methods simply cannot. Wire EDM is a game changer for industries that demand absolute precision. Its applications are vast and varied, making it an essential tool in modern manufacturing. Think aerospace, medical devices, and automotive manufacturing. These industries rely on wire EDM to produce parts that meet stringent quality and performance standards. Wire EDM is helping us push the boundaries of what's possible in engineering. As we continue to innovate and refine this technology, the potential applications are virtually limitless, opening new doors for creativity and precision in manufacturing. Let's break down how wire EDM works its magic. Wire electrical discharge machining, or wire EDM, is a fascinating process that uses electrical energy to cut through metal with incredible precision. It's a method that has revolutionized the manufacturing industry, allowing for the creation of complex and intricate parts that would be impossible to achieve with traditional machining techniques. The workpiece is submerged in a dielectric fluid. This fluid is crucial to the process as it serves multiple purposes. Not only does it act as an insulator, preventing unwanted electrical discharges, but it also cools the workpiece and the wire, preventing overheating and ensuring a smooth cutting process. This fluid acts as an insulator and a coolant. It also helps to flush away the tiny particles of metal that are vaporized during the cutting process, keeping the cutting area clean and free of debris. This is essential for maintaining the precision and accuracy of the cuts. A thin, single-strand wire, usually made of brass or molybdenum, is threaded through the workpiece. This wire is incredibly fine, often just a fraction of a millimeter in diameter. Yet it is strong enough to cut through even the hardest metals with ease. This wire never actually touches the metal. Instead, it is positioned very close to the workpiece with a tiny gap between them. This gap is where the magic happens. Instead, a controlled electrical spark jumps the gap between the wire and the workpiece. This spark is incredibly powerful, generating intense heat that is capable of vaporizing the metal in its path. This spark creates intense heat, vaporizing tiny particles of metal. The heat generated by the spark is so intense that it can reach temperatures of up to 12,000 degrees Celsius, instantly turning the metal into vapor. The dielectric fluid then flushes away the debris, leaving behind a smooth and precise cut. This ensures that the cutting area remains clean and that the cuts are as accurate as possible. The wire is constantly fed from a spool, ensuring a fresh cutting edge for optimal precision. This continuous feeding of the wire means that the cutting process can go on uninterrupted, maintaining the high level of precision required for intricate cuts. The entire process is controlled by a computer. This allows for precise control over the cutting parameters, such as the speed of the wire, the intensity of the electrical discharge, and the positioning of the workpiece. This allows for incredibly intricate and complex cuts to be made with repeatability. The computer control ensures that each cut is exactly the same, allowing for the mass production of complex parts with a high degree of accuracy.
Industry experts are buzzing about the capabilities of Wire EDM. Wire EDM allows us to achieve tolerances that were previously unthinkable, says Dr. Emily Carter, a leading materials scientist. We can now create parts with incredibly fine features and intricate geometries, opening up a world of possibilities for design and innovation. The medical device industry is a prime example of Wire EDM's impact. We use Wire EDM to create intricate stents and other implantable devices, says Dr. Mark Johnson, a biomedical engineer. The precision and accuracy of this technology are literally saving lives.
Section 4. Making it perfect considerations for Wire EDM. While Wire EDM offers incredible advantages, there are some key considerations to keep in mind. Material selection is crucial. Wire EDM is most effective on conductive materials such as metals. The thickness and type of material will impact the cutting speed and the overall precision of the process. The complexity of the part geometry is another important factor. Wire EDM excels at creating intricate shapes and small features, but highly complex designs may require multiple setups and longer machining times. Finally, it's essential to work with experienced operators who understand the nuances of Wire EDM. Proper machine setup, programming, and maintenance are crucial for achieving optimal results.
Section 5. Wire EDM versus traditional machining, a new era of precision. So how does Wire EDM stack up against traditional machining methods? Traditional machining often involves mechanical cutting tools, which can create stress and burrs on delicate parts. Wire EDM, on the other hand, is a non-contact process, eliminating these issues. Moreover, Wire EDM can machine extremely hard materials that would be difficult or impossible to machine using traditional methods. This makes it an ideal choice for applications requiring high precision and intricate geometries. Finally, Wire EDM offers greater design flexibility. It can create complex shapes and features that would be impossible to achieve with traditional cutting tools.
Section 6. Wire EDM Facts. Your burning questions answered. In this section, we will delve into some of the most common inquiries we receive about Wire EDM, providing you with detailed answers and insights. Let's tackle some of the most frequently asked questions about Wire EDM, from its limitations to its precision and even its cost-effectiveness. We aim to give you a comprehensive understanding of this fascinating technology. Q. What are the limitations of Wire EDM? This is a crucial question for anyone considering this technology for their machining needs. A. While incredibly versatile, Wire EDM is not suitable for all materials or geometries. For instance, it struggles with non-conductive materials like certain ceramics and composites. It is most effective on conductive materials such as steel, aluminum, and titanium. These materials allow the electrical discharge process to work efficiently, ensuring precise cuts, and excels at creating 2D and 2.5D shapes. This makes it ideal for producing intricate parts that require high levels of detail and accuracy. Extremely complex 3D geometries might pose challenges. The process can be time-consuming and may require multiple setups to achieve the desired result. Q. How precise is Wire EDM? Precision is often a critical factor in choosing a machining process. A Wire EDM can achieve tolerances as tight as 0.0001 inches, which is incredibly precise. This level of accuracy is essential for industries like aerospace and medical device manufacturing, making it one of the most precise machining processes available. The ability to produce parts with such tight tolerances ensures that components fit together perfectly, reducing the need for additional adjustments. Q. Is Wire EDM expensive? Cost is always a consideration when choosing a machining method. A Wire EDM can be more expensive than traditional machining methods due to the specialized equipment and expertise required. The initial investment in a Wire EDM machine can be significant. However, the incredible precision and ability to create complex shapes often justify the cost. In many cases, the benefits of using Wire EDM outweigh the higher initial expenses, especially for projects requiring high precision and intricate designs. In conclusion, Wire EDM is a powerful and precise machining method with specific applications and limitations. Understanding these aspects can help you make an informed decision about whether wire EDM is the right choice for your project.